What if I told you the universe holds secrets written in a language we're only just now beginning to understand? In this talk, I'll pull back the cosmic curtain and show you how scientists, myself included, use a mind-bending property of light called polarization to reveal hidden messages from the very dawn of time. Together, we'll explore how this powerful tool lets us hunt for traces of the Big Bang and unravel events that happened billions of years before human history even began. But that's not all. You'll actually be able to do an experiment yourself using this mysterious property of light called polarization, and I'll show you exactly how that works. And the story doesn't stop with physics. I'll take you right to the edge with me, where science meets spirituality, where facts confront faith. Can the universe's mysteries ever answer the age-old question, does God exist? I'll share why the line between evidence and belief is both blurry and fascinating, and why it matters for anyone who's ever looked up at the stars and wondered if there's more, if there's anyone looking back at us. Just when you think we've reached the limits of what we can know, I'll invite you to consider something even wilder. Whether or not we're alone in the universe, and whether or not our universe is alone. Or could it just be one among countless others? Expand your mind with me as I break down the jaw-dropping idea of the multiverse, life on other planets, and what they could mean for our place in reality itself. Curious yet? Good, because once you start down this path, there's no turning back. Come along with me on a journey. Together we'll chase down the answers to the biggest questions of all, unlocking mysteries that will change the way you see the universe forever. Don't just wonder. Dive in with me and my brilliant students, recorded live at UC San Diego in May 2025, and discover what's possible. Come on, let's go into the impossible.
If you were to look up at any star in the galaxy, you would have to really have some outrageous mountain of evidence to point to a star and say it has no planets around it, or say it has one planet around it, or 152.3 planets around it. Any number is ridiculous, but the most ridiculous thing is to say they have no planets around it. That zero, nothingness, flatness, zero, is a special number and needs to be explained. What is their evidence for life other than life on Earth? They would have to say as close as possible to zero. The question is there any life that started elsewhere ab initio and has come to our attention, either microbial or not? 2 weeks ago, there was a claim that there was a detection of the compound molecule called dimethyl sulfide discovered in a planet orbiting another star 123 light years away.
My name is Georgia, and I guess I'd like to understand a little bit more about polarization and if there is no Big Bang, then one.
Yes. I usually get that as this. I have a simple question. If the Big Bang never happened, what's beyond the Big Bang? So first question is, what is polarization? So polarization is the least familiar property of light. Light has two other properties that you're very familiar with. Its intensity, how bright it is, and its color, the red sign versus green or whatever. That's called its spectrum. So there's intensity and its spectrum. And both of those can vary, right? The intensity over there is dimmer than the intensity outside. The color can have intensity too, and we can have a continuum of colors. There's an infinite number of colors in the rainbow. Now that's just a very small sliver of the electromagnetic radiation. What James Clerk Maxwell, the father of electromagnetism, realized is that light is actually electricity and magnetism oscillating alternatively in what are called electromagnetic waves or radiation. All waves of radiation, electromagnetic radiation, whether they're radio waves or microwaves or infrared light X-rays. I used to come to this very building and get blasted with X-rays because my dentist was here. But they buried her in it. No, she's fine. So X-rays, gamma rays, radio waves, optical light, they all travel at the same speed, the speed of light. It's a wave. It can also act like a particle. That's a little confusing. But when it acts like a wave, it has a defined orientation, up and down, left and right, like a rope. If you have a rope and two people hold a rope and they shake it up and down, the plane that it's oscillating in is called the plane of polarization. Water waves can go up and down. That would be like their plane. Light, when it oscillates like this, it's the electric field, and we can tell that the light is polarized by looking at it with things that filter out one of the two different polarized components. You can only have a component up and down or left and right. And from that, you can make any pattern you like with it. That's how your glasses work. They don't have polarized sunglasses. Pay a little bit extra, they put a little P on there. Why that occurs, or why that's valuable, is because light, when it interacts with matter, like water or the road, becomes slightly polarized. Therefore, you can get rid of some of the unwanted light called glare by putting on polarized sunglasses that reject and suppress one of those polarization states, the one that causes the glare in light. So if you ever take your polarized sunglasses, look at the surface of the ocean, you're actually able to see into the ocean with the polarized sunglasses because they defeat and get rid of the glare. So that's what polarization is. The reason that it's important for what we do is that light gets polarized when it interacts with matter. Light from the sun is unpolarized. It hits the surface of the ocean, i.e. matter, becomes polarized, right? It can also get polarized from other types of matter. But when it hits the surface of the ocean, it's polarized. In the early universe, there was a primordial light that would become the cosmic microwave background. It was a form of heat that filled the entire universe. And that light and heat interacted with the primordial matter, the primordial soup that I showed you, that can of Campbell's pork soup. Light was interacting with it, therefore it can become polarized. We then use the properties of the observed polarized light to reveal the matter, the light, and the interaction between them. Polarization of light is used by satellites in space. A satellite in space can look at the ocean and the polarized light that comes off of it and learn about the direction the waves are going, learn about the salinity of the water, learn about the temperature of the water, because interaction of light with matter produces polarization. So that's why polarization is important. It's very unfamiliar because humans actually can't see it. About 1% of the population can see polarized light, and it's a phenomenon that actually could be bad. If you do see it, it means that you can have macular degeneration. So I won't do that. I'm not an optician. I'm not that kind of a doctor that helps people. But you will notice when you look at certain things, like the screens are polarized too. So I left my polarized glasses at home. They don't have their polarized sunglasses with them. Nobody has them. You guys should all have them. It really prevents cataracts and things like that. You have a pair? Yeah. Can I see it? Okay. So I'll do a live demonstration. So there's light coming out of these screens. The light is coming from little tiny shutters that interact the visible light with the matter of the screen. And if these are really color, we're about to find out if he got ripped off because they do charge more money. Okay, so we're gonna cover up Jonathan. And then you see when I put it like this, Jonathan goes away. That's because these glasses are only letting in light that's polarized like this. The light from the screen is polarized like this. So it's completely orthogonal. So it blocks out all the light from here. Now, when I rotate it 90 degrees, it goes to be completely transparent, but that's not all. Watch this. I don't have to rotate it 360 degrees to repeat that pattern. I only have to rotate it 180 degrees. So watch this. Now it's completely transparent, or it's 50% transparent technically. Now it's 0%, right? And now it's gonna go back. We're gonna put it this way. Now it's back to transparent. And now it's back to opaque. It darkens and lightens twice every time I rotate this once. That's because it's a wave. The wave only has an orientation up and down. If I show you this wave going up and down, and you're looking from the edge, you can't tell if it's instantaneously going up. It's just like a straight line. Simultaneously, I could go like this. This is like a picket fence. It only lets in one polarization state. And that's why my good friend did not get ripped off. Congratulations. Thank you very much. Your next question was, what if there was no singularity in the Big Bang? If I interpret the question correctly, is that correct? So it's a very difficult question to answer, but those are the alternatives that we're left with. It's akin to saying, what if the Earth is not flat? There's an infinite number of non-flat shapes for the Earth. Do we agree on that? You could have a perfect sphere of any radius, and the number of different radii that are possible for the Earth or any sphere is infinite. It goes from 0 to infinity, right? And I don't mean different shape, spherical or donut shape, but it's like saying, how many different types of non-dogs are there in the animal kingdom? There's a lot, right? There's a lot of non-dog animals. It's not very specific. But if you say something specific, you're saying the Earth is flat. There's only one flat Earth, right? It's perfectly flat. Okay, I'm not saying that again out there listening. Pradeep Khosla, my chancellor's listening. I don't believe in the flat Earth, but you're not able to actually disprove an infinity of other alternatives. You could disprove the one that makes the most precise claim. Actually, it's more precise to say Earth. You're saying something very specific when you say the Earth is flat. The curvature is exactly 0. If you make a triangle, all the angles add up to be 180 degrees. Parallel lines do not meet. The laws of Euclid hold. So there's an infinite number of alternatives, but there are only a handful that are actually studied, and very few that have the kind of firepower of money, of attention, of scientific researchers working on it, as does inflation. So we are actually looking for these waves of gravity because if we detect them, it will rule out these other alternatives. One of which is the universe is eternal. Another one is that our universe came from a previous collapse of a single universe before it. Another one is the universe keeps cycling into and out of existence for all eternity. Another one is that the universe exists in this temporary phase that we're in, where it had a Big Bang, but it will continue expanding forever. Another one it had a Big Bang, but that Big Bang is not a singularity. So there's many different alternatives. This is designed to basically refute as many of those as possible, because none of those predict that this B-mode polarization pattern in the microwaves from the heat from the Big Bang will be inserted.
A simple question, right? Simple question, but
Does God exist?
we've had some discussions about this issue of there being more than just the Earth and so on. And this is just an outstanding kind of discussion that you had.
Thank you.
But I'm wondering, as we get older, we're also thinking about what's going to happen for us in the future, and we begin to think about religion. So now the question is, so you look at the Bible, and you look at it when it was written, God and Jesus saw. How does all of this relate to religion?
So literally, we're asking about this. So I always say, again, I say I believe in gravity, right? I have evidence for gravity. I'm actually Jewish, so my religion is Judaism. I actually practice Judaism. But I was a Catholic altar boy in the Catholic Church, and I didn't have a bar mitzvah at age 13. I was an altar boy in Dobbs-Ferry, New York, in Westchester County. Again, read the book. There's still 7 more copies left. Thank you all very much. Kids are gonna eat some kosher food tonight. So, I always say that I didn't have evidence for God, and that's fine. If you had evidence, you wouldn't need faith. Right? It would be as foolish as not believing if you step off this third floor balcony, that you'll end up in a pretty bad condition. The end of your life, as you mentioned, will come much quicker than anticipated. So you want to have belief in things is where you don't have evidence. You can only have faith. In fact, the word for faith in Hebrew is emunah, which is where we get the word amen from in Christian and Judaism. And Christianity and Judaism, and that is something by nature that's not necessarily provable. And in most religious contexts, at least the 2 that I'm familiar with, Judaism and Catholicism, you don't get credit for believing in things that are obvious. Like, you don't get credit for loving your child. You should love your child. It's not like a hard thing. It's hard to love your parent though, right? For many of us, I made a joke the other day that I'm very familiar with divorce because my parents had 3 of them between them. So, you don't and so it wasn't an easy childhood. It's hard to do something, so therefore you have to be commanded to do it. In the Jewish tradition of the Torah, you're commanded to love God. That's kind of strange, right? God, it means that God doesn't see himself as intrinsically lovable. Because again, you don't have to be commanded to love a beautiful puppy or your infant grandson, right? You just do. It's the natural order of things. So I don't look for my science. I don't look to the Torah for scientific reasoning. In fact, I mentioned that the actual creator, if you will, of the Big Bang Theory was a Belgian Catholic priest. In other words, a Catholic priest. He was a father, Lemaitre. He was from Belgium. I actually know one of his students and interviewed one of his students who's an eminent cosmologist and an astrophysicist at the University of Wisconsin named Francis Halsey. He knew the originator of the Big Bang. It's amazing how many people you can know or be connected to. And that man knew Einstein very well. And Einstein knew people before him. And as soon as you get back to Newton and Galileo, and it's not that hard to go hundreds of years back. But when you think about these people, they didn't want the scientific discovery that he made and predicted, really. He was predicting a theory. He told the Pope at the time, do not use this to justify Christianity or Catholicism. It's beyond the scope of what I'm conceding to be true. And it's good because actually some of the things he did predict are wrong. The universe didn't start as a primeval atom. There was no nucleus somewhere, sitting somewhere, and then it exploded. That whole concept makes no sense. The universe was denser and was like a primeval atom everywhere in space. But he didn't say that. So imagine the Pope surprising him by saying, this proves that the Big Bang's account is that consistent with the Old Testament. And he did do that, the Pope at the time, Gregory, I think it was. So it was a very uncomfortable thing when later it turns out, was God wrong? And there's actually scientists now who are in the Jewish tradition. There's a rabbi, a famous one named Gerald Schroeder, who tries to make the biblical account of the first 7 days of creation match up with things like inflation, the formation of the elements, the hot density of the CMB, and it's complete and utter nonsense. And I tried to be in contact, actually spoke on his home territory, Asia Torah, at the old city of Jerusalem 2 years ago when I finally did have my bar mitzvah. I actually had my bar mitzvah, 52 instead of 13, better late than never. I'm told I'm not the first bar mitzvah kid to have his wife and kids with him, which is kind of weird. Apparently someone had just done it who was 13 in Auschwitz. So it's a pretty amazing experience to have that at the old city in the Kotel. Anyway, all this is to say, I love to have them thought about. I love thinking about both of them. But I never let the science kind of impact my quest to understand God, if God exists. I admit, scientifically, I have to be open to the possibility God may not exist. But you also have to be open that there's a possibility that God could exist.
First of all, I'm going to tell you, I laughed at the croutons. Split the dad joke. I'm going to ask the impossible, which is, I'm going to ask you to prove a negative. You said at the very beginning that Homo sapiens are the only ones who are aware of their own death. But I would suggest that that is perhaps not true, because there are animals who highly show a sense of danger, and they would only be able to show or sensitivity to dangerous situations. And it would seem to me that they would not be able to do that unless they had some concept of the results of dangerous situations, which would mean they had some kind of concept of their end.
Yeah, that is a very interesting complaint or response. I have heard similar complaints and responses. I have also heard it said that there are animals who actively appear to engage in death-like rituals. Elephants are reportedly, when one is about to die, they encircle the other ones, or when there's danger. I guess there's a famous thing that happened a couple of weeks ago, right before Easter or after Passover. There's an earthquake, and then at the San Diego Zoo, former Vice President Kamala Harris said that this was very inspiring to see the elephants circling around because they knew there was danger. I think danger and evolution are certainly related to one another, that the creatures that are most likely to persist in their germline to disseminate their genes are those that have a survival instinct. Whether that is extendable to the lowest animals on the kind of pyramid or hierarchy of life. All animals or all creatures that have evolved, you could say, have some essence of wanting to extend their genes into the future. I've talked to Richard Dawkins many times. I hosted him for an in-person conversation last fall. And he believes that the gene is the fundamental unit that has a desire to extend its existence and propagate. That means the gene, according to, is it Susan? Asked the question. Who asked? Okay. That means that in your conception, which I'm not vehemently disagreeing with, that even genes, which are assemblages of chromosomes, which are themselves only assemblies of amino acids, which are so at what level does that actually get instantiated? Is it at the gene level? Well, the genes are just made of chemicals. So do chemicals have a perception. I think it's a stretch to say that they're aware of death in a way that a gentleman asked before, like, oh, we're thinking about our death. I interviewed Deepak Chopra, not someone that you think of as a great scientist, maybe perhaps, but he actually has written papers with multiple Nobel laureates that I've had the honor to speak to. And he said that the last 25 years of his life, he's just been preparing to die. He wasn't morbid about it. He was just thinking, I need to make plans for the preponderance of the state of my atoms will be in a state of death, which is a fact, right? We spend more time, our atoms will be recycled back in one way or another. So just think the letter of what you're saying is true, but the spirit of it is that we are imbued with a sense of what the Stoic philosophers called memento mori, that you should be aware that you're going to die in order to invest your life with meaning now. I don't think an elephant is thinking, well, like, I'm going to die someday, therefore I'm going to, they're reacting on instinct. Or a cuttlefish or an octopus. Octopuses have existed for 60 million years without brains. And in the same way that we have brains, there are jellyfish have existed for millions of years without brains, which gives hope to many of my colleagues that they too will have a long existence. So do they also, because they have a desire to preserve their genes, do they also have an awareness of death? I'm not disputing, I'm not arguing. I'm just saying there's a distinction between the letter of what you're saying, which I agree with, and I think the deeper spirit or philosophy of it.
And Gary, I can't hear in your age. Thank you, Brian, for the very entertaining presentation. I'd like to draw your attention to a graphic that showed up on the cover of the New York Times that you've presented in previous lectures to us. So there was the initial expansion, and then we have what we have now. And in between, there was this enormous inflation where linear dimensions expanded by 10 to the 26th and so on and so forth. And so the question is that something that was stuck in there because they have no other way of getting from point A to point B, or is there proof that such a rapid inflation took place?
It's really related to the first question, which is, the alternatives to inflation. So we exist, and there are people that say everything is conscious. I'm not interested in entertaining those kind of discussions, but suffice to say, people believe that consciousness is elemental, literally. We exist, and so we are naturally wanting to explain how we came to exist. We are made of matter. There are materialists who believe everything can be explained by laws of physics, laws of matter, energy, assembly thereof. Even if we can't explain it ourselves with our limited knowledge, we don't have to invoke something supernatural or whatever. Many people believe that, as I showed the final couple slides, Paul Davies in particular, who is religious, he's a religious Christian, who says that actually a lot of what the multiverse, which is an inescapable conclusion that comes from inflation theory, we cannot have inflation without the multiverse. And if the multiverse is true, it kind of looks like a lot of religion, but dressed up in scientific language. That's what he literally says. So the alternatives to it don't invoke that. That's why Steven Weinberg found the other models much more tasteful, because they didn't have at least the rhyme, as Mark Twain said. History doesn't repeat, but it rhymes. They didn't seem like Genesis, and he liked that. And he was an atheist. It didn't influence it scientifically. So inflation, again, so what was the Big Bang designed to do? If you were back then, Jerry, you might say, wasn't the Big Bang just designed to explain why these galaxies are moving away from us? In a sense, yes. In science, you could do one of two things. You can kind of inductively understand observational data that you saw. Oh, Mercury doesn't orbit the way we think it should. Therefore, either gravity's wrong or there's some planet closer to the sun than Mercury, and you can induce that there might be a law, like the law of general relativity. That's how it happened. Or you can make a prediction of something. You could say that because these equations also predict the universe is going to either expand or contract, it's not going to be static, that's an inevitable deduction from observations from empiricism. So if you were around back then, you might rightfully say the Big Bang itself was created to patch up this problem that the universe is expanding. Fine. But then we have problems with the Big Bang. There are things in the Big Bang that we can't explain. Why is the universe so uniform, so isotropic, so homogeneous? Why does it appear very stable, admissible to life? So we have to add on something to that to explain why that's happening. There's no such first axiom that's given to us by God, like the so-called piano axioms of arithmetic. No, we don't have those things. But we can say that there are simple explanations in the Occam razor sense, and those might be more likely to be true. Right now, there are some huge glaring problems with inflation, but it also explains a great deal of information about the universe, including theoretically, why did the universe start expanding at all? It could have started expanding or contracting rather than expanding. We wouldn't be here to answer that question. So, yeah.
Actually, I got a couple of questions. I want to double check with what I think you just had, which was, it would be only, how did you close it? You have to have a multiverse if you have inflation.
So the reason I say the multiverse, and it is, again, it's not me, it's two founding fathers of inflation, at least in its modern sense, Andre Linde and Alan Guth, who actually came up with inflation to begin with. By the way, when inflation was created, it also had these huge flaws in it, and some people that have objected to inflation were some of the very first people 45 years ago who said that inflation isn't perfectly right, it needs to be corrected, and then they came up with their own theories that don't even have inflation whatsoever. But the two founding fathers that most people associate are Andre Linde and Alan Guth. They both seem to agree that you can't start off assuming there's a one. Universe means one. Verse means to roll. I don't know why, but the most means that in Latin again. I love entomology and I love etymology. And apparently that's what it means. So Andre Linde screamed at me and said, why do you assume that it's a universe? Why don't you start with there being a multiverse? After all, if you were to look up at any star in the galaxy, you would have to really have some outrageous mountain of evidence to point to a star and say it has no planets around it. Or say it has one planet around it, or 152.3 planets, or any number is ridiculous. But the most ridiculous thing is to say they have no planets around it. That zero, nothingness, flatness, zero, is a special number and needs to be explained. You couldn't explain it. All the evidence we have from the Kepler telescope is that every star has at least tens or hundreds or maybe thousands of planets, comets, icy bodies, asteroids, meteoroids, etc., etc. Except for the lucky few of you that got your own meteorites here. And so, because of that, they say you are universe biased if you claim the multiverse is unnatural. And actually, 34 of them, including 6 Nobel Prize winners, wrote articles to Scientific American to criticize the people that say the multiverse is wrong. It was like this Inquisition battle between the heretics and the true believers. It's a very contentious thing. That makes it very interesting to be a scientist to possibly shed light, if you will, excuse the pun, on whether or not the universe did start with inflation. Because if it did, there would be a period of inflation, would lead to these gravitational waves. That would lead to the B-mode polarization that we thought we saw, but was really dust. Now we think we can get rid of the dust and see if it's really there. And then that would mean we live in a multiverse, according to most people. Second question about the James Webb Space Telescope, not as much as influential. It's not impacting the origin of the universe or inflation, because it sees back only, quote unquote, to when there was light that it can detect. Because light gets redshifted, a wavelength of light that's associated with visible light is younger from younger galaxies that are closer to us, and that's what the Hubble Space Telescope saw. The Webb telescope can see twice as far back in redshift, if you will, than the Hubble Space Telescope because it can see infrared light. That's what it was designed to do. But none of them can see microwave light, which is what the oldest light in the universe is. The Hubble Deep Field that I showed you earlier on with Baby Einstein and Big Einstein, that's from about 1 billion years after the Big. Webb made its own version. That's from about 500 million years, so 500 million, 1 to 500 million years after the Big Bang. There were actually galaxies around 100 million years or so, 200 million years after the Big Bang. But the microwave background goes back to 100,000 years after, 1,000 times farther back in time. So the Webb can't really tell us anything about inflation. Only the CMB could. Next question.
Hi, my name is Janet Winders, and this is probably a super silly question, but every time I hear about the universe expanding, so if the universe is everything that we can see out there, what is it expanding into?
Another very simple, trivial question. This is people always will ask this question, and for a while, I'm like, well, I could really spend a lot of time talking about it. But in reality, it's a very good question. It's a very fundamental question. It goes back thousands of years. I think it was his name sounds like Achilles, but I can't remember. It's not Achilles. It's somebody else with stronger feet. But he said, if I go to the edge of the universe and I throw a spear, what is it going to? It's exactly like what you're asking. So it turns out there are a couple ways to answer this question. One way is to be flippant and say it's not expanding into anything, and then people will make these analogies of balloons, and the balloon will be the following. I'll have these little dots on it on the surface of the balloon, and then I'm blowing up the balloon. It's getting bigger. The space between the dots, you could draw them looking like galaxies. They'll be moving apart from each other. You agree? And then every galaxy could say every other galaxy is moving away from me. Therefore, I'm the center of this two-dimensional universe. Okay, does that make sense, Janet? So that's a two-dimensional analog. Unfortunately, there's a lot of problems with that because you're blowing up a two-dimensional object inside of a three-dimensional room, so it is expanding somewhere. The balloon does have a center, but now imagine that you had this infinite sheet, which the human brain really can't visualize infinity, but imagine this two-dimensional sheet, and you just keep stretching it out. But it goes in all directions. You can't see the end of it. You can't see, and you're just sitting on one part of it where there happens to be someone painted a galaxy on it. But your eyes can only see light that goes along this sheet. That's the concept. It was actually introduced by this wonderful writer in the 1880s. I'm doing a special podcast tomorrow about it. I'm called Edwin Abbott, and he wrote a book called Flatland. It was the first book on science I ever read. And the book is written by a character, and his name is A Square. And he is a square, and he lives in a two-dimensional world called Flatland. And there are creatures that live in there, and their number of sides on their polygon, because that's all they could fit in there, are polygons. The number of sides determines your social caste. So a square is kind of like, a little bit above average IQ. Triangles are low IQ. They're considered to be like laborers, and they get the lowest status of the men. I'll get to what the women are in a second. And then the high priest, the presidents, the governors, they're circles. So the number of sides of your polygon determines your social caste system, your stature. Women are lines. Now, he was writing in Victoria-era England to point out how sexist that culture was and how racist it was, because the laborers were basically Indians and blacks and from Africa. So he was writing a social commentary about how incredulous that was and how bad that was for society. But leave that aside. He teaches you what it's like. One day, he sees this shape come into existence. And at first he thinks it's a little baby circle coming towards him. And then the circle gets bigger in real time. It's like he's growing. And then the circle shrinks like he dies and goes away. And over time he realizes what he saw. It was a sphere that came from the third dimension. Oh, and by the way, it's forbidden, it's illegal, it's a thought crime to consider or talk about the third dimension. And in so doing, he reveals a narrative and teaches us how it is to visualize the fourth dimension. Our brains are amazing. We take in two-dimensional information. Our retinas are two-dimensional, right? They're just these like detectors on your phone. Your camera on your phone is a two-dimensional array of transistors. But your wet retina, your wet CCD camera in your head is basically two-dimensional. We have two of those, and from the two of them, we can make a stereographic image and kind of reconstruct depth. But I can't see into you. I can't really see three dimensions. I see the surface of a three-dimensional object. So too, we can't make a perfect analogy for the expansion of the universe into anything, because it's not expanding into another dimension like the third plus one dimension. It is already the third plus one, it's the fourth dimension. So space and time together, and humans cannot really visualize that. But listen to the podcast tomorrow when you get this example of what it's like to imagine yourself as a square or a triangle or a line, very dangerous creatures, because the lines can, the sharper, the more acute your angle is, the more dangerous in this culture. Okay, next question.
We should be speaking further aside from your topic today and more things that you see bring up on your podcast. We just finished a book by Sarah M.R. Walker and her assembly hypothesis, which argues that we may be the only life of the type of intelligence that we are in the universe. I also know from your friend, basically, what are your thoughts about the existence of life and us having it?
Yeah, so thanks, Nina. So the question is, if you didn't hear it, what are my thoughts about the existence of life outside of the Earth, presumably? Although you guys do know what the SD in UCSD stands for. Does anybody know? The University of California, socially dead. socially there, because the students are so brilliant. They only work on snow. They don't have as much of a social life as probably they deserve, but then again, they're much more. So if you ask me right now, if you said, I'm going to kill your pet orchid or whatever, your cuttlefish, if you don't answer truthfully, and you put a gun to any scientist's head right now and said, what is their evidence for life other than life on Earth? They would have to say as close as possible to zero. There's almost no evidence. The only evidence, in fact, for life outside of the Earth is in space, and it's from the venting of excrement from the International Space Station. And there are microbes that can survive in harsh radiation and low vacuum and cold temperature. There are also probably those microbes on Mars, or creatures called water-bearing tardigrades. They can exist without, basically be dormant, but they originated from Earth. So the question is there life that started elsewhere, not from the Earth, and went out into the solar system? And right now, despite all the searching, and according to me, there's been a lot of searching, according to my friend Jill Tarter, who is really the inspiration for the movie Contact with Jodie Foster. It's a great movie. I just watched it recently. Again, with my kids for the first time. It's kind of cool. 30 years old, all right? But there's a scene in the movie, if you remember, when Bill Clinton makes an appearance. And he comes out and he's talking about the discovery of life in the universe. And it's not CGI. He actually did talk about the discovery of life in the universe. And what had happened was, in 1996, there was a meteorite, not unlike the meteorites that you get if you buy one of their many copies of Losing the Above Pride. And it was found in Antarctica, and it had what was claimed at the time to be microbes embedded in fossils of microbes embedded in it, meaning that there was life that had originated on Mars that made its way to Earth, landed in Antarctica, and then was dead. It wasn't alive anymore, but there was evidence of fossil life from Mars. And it was clear it came from Mars. I actually have a fossil of Mars. Not a fossil of Mars. I actually have a Martian meteorite, which is very expensive. Much more, I can't give them away because they're thousands of dollars per gram. But if you have a large podcast invitation for me, I might bring one on. I gave it to Joe Rogan, and I gave him a small sliver. And I think he tried to think it was like a drug or something. So he smoked it or drank it or ate it. Anyway, and these are very expensive, but it shows that material goes from the Earth to Mars and Mars to the Earth and vice versa. The question is there any life that started elsewhere ab initio and has come to our attention, either microbial or not? 2 weeks ago, there was a claim that there was a detection of the compound molecule called dimethyl sulfide discovered in a planet orbiting another star 123 light years away. And then it was pointed out that that only is produced on Earth by humans in chemistry laboratories here at UCSD, and you can buy a gallon of this stuff apparently, or it's produced by algae and microbes in the sea environment. And so it got a lot of attention. It was in the New York Times, and people made a big deal about it. And then people started to point out, including people like Sarah Walker, who you mentioned, Yanina, and others who I've had on the show, start pointing out that it was actually discovered on comets before that. And it's been in our own solar system. Now, clearly there's no chemistry factory, there's no life, there's no microorganisms on that. So it's very premature to think about that. But even if it existed, this planet is 5 times the size of Earth, the size of Neptune. There's no advanced life. There's no Netflix coming from this star or this planetary system. And so far as we've detected, there's no proof that's beyond, a credible amount that life exists anywhere but here on Earth. So it's an open question. So right now I say it's a very low probability. It may only exist in one planet, in one instance in every galaxy. And there are hundreds of billions of galaxies, so there might be tons and tons and tons of planets and life, but we are so far away from them, we'll never encounter them. As Carl Sagan said, if that's true, it's an awful waste of space, but the universe is under no obligation to make, high efficiency use of its space.
This is fascinating. Thank you. So if studies really depend on the brilliant minds and the physical equipment that you have at the time of the study, what's your take on how AI will affect your studies?
How many of you, I'm curious, how many of you use AI? Okay. So yeah, someone was asking me about the movie that I showed with the opticians in the Netherlands in 1600. That was made purely from AI. I actually had a prompt. I said, sketch, a Dutch spectacle maker, taking glasses, and then that leading to the printing press then being used as an eyesight test. And it starts with an image, and I said, animate this, and I put in all sorts of cool stuff. And it's not perfect. It made there's some weird choices that it made that Steven Spielberg probably wouldn't make, but it was free, or $20 a month. I use it all the time, and it's really leveraged and allowed me to do a lot more than I could have done otherwise in terms of supervising students, analyzing research papers. When I started in graduate school, there was this website, it's called the Archive, and every day there would be published 4 papers about cosmology, maybe. Nowadays, it's like 400 papers, sometimes 1,000 papers in my specific field, and there's literally 400 different fields that are listed on the Archive, with an X and an E at the end. And it's also a sponsored Edge assignment, so it's an incredible resource. I use it all the time. The question is, can it do the things that physicists do? Is my job in danger? And can it expand upon what we can do? Again, I'm kind of a little bit of a contrarian, or people call me a downer. I don't believe that there's abundance of life in our galaxy, or let alone beyond our local corner of Earth and solar system. I also don't believe that AI is going to reproduce the laws of physics in a way or produce new laws of physics. And, for example, predict new particles or observe dark energy and detect what it is, or dark matter, without an intimate partnership with people. There are stories abounding about how scientists were able to do things purely on intuition, which we don't really understand. It's almost like art. Like, have you seen some of the AI art? It's nice, but there's also something uniquely missing from it that is seemingly human. On the other hand, I took my son last month after I went on Neil deGrasse Tyson's, I took my son to meet him, and Neil is his favorite astrophysicist. Very painful. And then I took him to the Guggenheim, because I went there when I was a kid. I tried to ride a skateboard down the rotunda. They kicked me out permanently and the rotunda's closed. But I took him, and we were walking past this thing, and we walked past it. It's about the size of this logo, and it's black lines, and there's a stripe, and it's behind glass, and there's an armed guard next to it, and it's a $68 million Mondrian. It's beautiful to some people. And then literally, we're going down the staircase to go to a gift shop, and there's an electrical access panel, and it looks identical, and no one's guarding it. And it's so subjective. So I'm not saying that there's this the machine and humans do this uniquely thing, and AI can do much better art, in my opinion, than that piece of Mondrian. I didn't care for it. I'm not here as an artist, but I didn't care for that. There was other stuff too that was like a dinner plate set up with a TV in the middle, and that was like $100 million. But there is some modern art. And the point is, the kind of missing ingredient that no one's been able to do is say, set AI loose and do what a human can do. And I'm not saying it's impossible, just like I'm not saying life is impossible outside the Earth. But what I am saying is that we have developed a very specific type of AI. And like the iPhone, it's going to be a victim of its own success. Does anyone have an iPhone here? Does anyone have an Android here that used to have an iPhone? Has anyone, in other words, migrated? You have. Wow. You have my utmost respect. It's very hard to do that. They get you locked into this garden, and now you can talk to your wife, and you could, I know where she is. It's very hard to, I'm sure you could teach me how to do it. I'm just too lazy, but that's called lock-in. When you get something, the technology is so successful, it's very hard to break out of it. AI is like that, in my opinion. And what is AI right now? It's computer processing chips called graphics processing units, or GPUs, which are very good at solving math problems that are good for games, that produce images like Minecraft and rendering this extremely fast, extremely efficiently. It does what's called matrix and linear algebra. Very accurate. That means it has to discretize the universe in order to make it seem accurate, and the more densely it can discretize the universe, the more pleasing it looks, more realistic it looks to the human eye. So too, there are LLMs, ChatGPT. I used it to make those pictures. But it's very different to use a language than to use imagine a creature that doesn't know English or Mandarin, but it does know all of mathematics. It somehow knows all, and it's able to construct proofs and arguments, which, by the way, no AI can do right now. No AI can prove Fermat's last theorem or the Pythagorean theorem without a lot of input given to it ahead of time. You don't just turn these things on always. So I'm optimistic that, at least for the foreseeable future, because of the success of GPUs plus LLMs, that'll be very hard to get new types of physics engines that solve physics. Okay, last question.
I'm David Nazareth. As a kid, I was ambitious. I wanted to know everything there was to know. I did well in college. I did well in medical school. in retirement or continue to read, but I'm always stymied and humiliated by Schrodinger's cat. So in my despair, I asked the professor what to do. He said, draw a circle and then put a dot in the middle of it. Well, my question of you is, in comparison to my minuscule dot, how large is Brian Keating's dot?
Wow. I wish my mother-in-law was here to refute that question. I am very impressed just saying it. I'm looking out on you guys. You probably are successful enough and have done well enough in your life, in your families, in your careers, and in your retirement to devote what could be leisure time spent, on the beach or doing whatever you want on the golf course, not to say anything negative about it. But you chose to enrich your life by coming to a talk, which I hope to deliver some value to and inspire some questions. And I think there could be a selfish purpose to that, in that you actually do maintain more mental agility the more that you learn. And I love the fact, I think that's one of Osher's missions, is to never stop learning. There's no point in stopping learning. I think when you stop learning, I'm also a pilot, and I'm always trying to learn new types of airplanes or systems or get new ratings, and I've worked my way up pretty far. And one of my flight instructors said, the day you stop learning is the day you stop living.